As we continue our discussion here in Chapter 3, we're going to look at Section 4, Finding and Using Slopes of Lines. This should be pretty familiar to you, and hopefully as we get going here, you'll realize that you already know most, if not all, of these things. So, first of all, slope, remember that's the ratio between the vertical change, or we call it the rise, to the horizontal change, which is called the run, between any 2 points on a line. And the formula that we use for finding slope of a line is the change in y, so y2 minus y1 over the change in x, x2 minus x1. So recall, okay, fortunately I can color coordinate here. So negative slope falls from left to right. Okay, a positive slope, the black line, rises from left to right. And then recall that a vertical line has a slope that is undefined. So that would be an undefined slope. And the horizontal line will always have a slope that is 0. Okay, so again, just a quick review of different types of slopes. The two that obviously most people get confused are vertical lines and horizontal lines. You just have to take the time to memorize both of those. Okay, so let's find the slope of line A, B, C, and D. All right, so we can do some of this very quickly. Okay, if I look at line, for example, line C is a horizontal line, so without doing any work at all, I know that the slope of line C has to be 0. I also know by the same argument that the slope of line D, since it's a vertical line, goes straight up and down. The slope of line D has to be undefined. Again, it's a vertical line. And now I got to do some work here for line A and line B. So for line A, change in y. So I have, let's see, I have 2 points here. I have 8, 2, and I have 6, 4. 6, 4 is on all of the lines, okay? So I have 8, 2, 6, 4. So change in y, 4 minus 2. Now here's the critical component. If I started with this 4 on top, I better start with the 6 on the bottom. So 6 minus 8. Otherwise, my sign will be wrong. 4 minus 2 on top is 2. 6 minus 8 is negative 2. 2 over negative 2 is negative 1. And then the slope of line B, again, I have 4, 0, and 6, 4. So subtract your y coordinates on top. 4 minus 0. Again, I started with 4 on top, so I better start with the 6 on bottom. So I have 6 minus 4. So on top, I get 4 over 6 minus 4 is 2, and 4 over 2 is positive 2. All right, so, and that's, again, just a quick review in terms of how to find slope of lines. So recall that the slopes of parallel lines, two lines are parallel if they have the same slope. Okay, two lines have the same slope, then that means that they're parallel. Note here that any two vertical lines are always parallel. They do not have a slope. It's undefined, but it's understood that they are still going to be parallel even though they technically don't have the same slope because they don't have a slope. And again, another idea that you should already be familiar with is that the two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. This is the other way to think of it. Okay, their slopes are negative reciprocals or opposite reciprocals of each other. Okay, horizontal lines are always perpendicular to vertical lines. So we'll kind of look at these ideas here on the next few slides. So it says line N passes through 1, 6, and 8, 4. M passes through 0, 5, 2, 12. Are they perpendicular? Okay. Find the slope of line N first. So I have my point up there. So I got rise. So 6 minus 4 over 1 minus 8. So that's 2 over negative 7 is my slope there. And then for line M, subtract your y coordinates. 12 minus 5. Since I started with 12, I better start with 2 on bottom. So 12 minus 5 over 2 minus 0, that's 7 over 2. And when I compare these, notice this one is 7 over 2. This one is 2 over 7, and it's the opposite, so it's the opposite reciprocal. Remember, reciprocal just means flip-flop the top and the bottom. Okay, and since they are opposite reciprocals of each other, we would say yes, they are perpendicular because they are opposite reciprocals of one another. The other way of thinking about it, like the notes already explained, if you take negative 2 over 7 and you multiply it by positive 7 over 2, when you multiply that out, this 2 and this 2 cancel, it'll get 1. 7 and 7 cancel, it'll get 1. And so the product of those two things is negative 1. Okay, another way to think about it, I just like saying it's the opposite reciprocal personally. Find the slope of each line, which ones are parallel. Okay, you can subtract, or better yet, if I give you two lines on a coordinate plane, you can just count. So in other words, to find the slope of K1, the blue line, I start here. I got to go up 1, 2, 3, 4, right 1. Up 4 is positive, right 1 is positive, so my slope here is just 4. For K2, I start down here. I got to go up 1, 2, 3, 4, right 1. Up 4, right 1 is positive 4. And for the last one, I start down here. I go up 1, 2, 3, 4, 5 over 1. So my slope here is 5 over 1, which is 5. And clearly now we can conclude that K1 is parallel to K2. All right? Because they have the same slope. H passes through 1, negative 2, and 5, 6. Graph the line perpendicular to H that passes through the point 2, 5. Okay, so first of all right, I need to find the slope of the first line. Okay, so when I find the slope of that first line, I have 6 minus negative 2 over 5 minus 1. That changes to plus plus, so I have 8 over 4, which is 2. Okay, so if the slope of my original line is 2, then the slope of the line perpendicular to it, so slope of the perpendicular line, has to be negative 1 over 2. And that's all we're going to need here now. Okay, so I don't think it says to graph the original, does it? It just says graph the line perpendicular to H that passes through 2, 5. So I know the point 2, 5 is on my line. So 2, 1, 2, 3, 4, 5. So that point's on my line. And now all I need to do is use this slope. Negative 1 over 2, that says go down 1, right 2. Down 1, right 2. All right. And there's my line. Something like that. Okay? And that would be the line that's perpendicular. Pretty straightforward stuff. Again, if you were asked to graph the original, you would graph the original, and you know for sure that wherever that graph is, that this has to be a right angle because they're perpendicular. It says a trucker made 3 deliveries. The graph shows the trucker's distance to the destination from starting time to the arrival time for each delivery. Use slopes to make a statement about the deliveries. So part A says the rate at which the trucker drives is represented by the blank of the segments. Okay, the rate at which he drives is represented by the slope of the segments. Segments blank and blank have the same slope. Okay, now I can't say for certain here because I haven't found it, but it looks to me like if any two have the same slope, it would be A and C. So segments A and C have the same slope. So deliveries A and C were driven at the same rate. Okay, so again, that's just interpreting a graph using slopes to interpret a graph. All right, and so again, that just kind of summarizes this section. Again, hopefully most of it's review, if not all of it. And as we come into class, we will obviously dive a little bit deeper into these ideas, answer any questions that you might have, and just get some more practice with this stuff.